Hello everyone. Today I'm going to show you how we can solve flexibility method if we have a beam. So here we have a beam. It's applied force 5 kilonewton, and we have also a moment. And the question is ask you to determine the internal forces and displacement at point C. So first of all, we should check the structure, if is it determined or indeterminate. So here we have a beam. The beam, we have different rule. It's the number of unknown minus number of equation. So here the unknowns, we have three unknowns, and because we have a fixed one, this is the force on horizontal direction, reaction on vertical direction and on horizontal, and also we have a moment and A at 0.8. But for B and C, we don't have any supports, ruler or pin or hinge, or also fixed, we don't have, so it's 0. So we have only 3 unknowns minus 3 equations, summation of force on horizontal and vertical, and also moment. We have 3 equal 0. So this is the determined structure and stability. Second step, we assumed on each force we have assumed 1 kilonewton. So here in this figure we have two forces. I mean one force, one applied force and moment. So now you should divide your structure for two parts. The first part is assumed we have applied load on P node is 1 kilonewton. This is the number 1, plus the other force or moment is 1 kilonewton time m, because this is the moment. So this is called R1 and this is called R2. Okay, and the same dimensions, this is 3m and this is 2m, 3m, 2 meter. Second step, we should find the force or the law of force, F equal TR time R plus TX time X. For the X, we don't have to, this part will be equal 0, and because it is determined structure. And for TR is found by internal forces, and R is we already have. This is the R, we have 5 kilonewton, and the moment. So the R matrix equal 5 and 2. For the TR, we should take one by one. This is a beam, and this is the force 1 kilonewton. This is 3 meter, and this is the 2 meter. So now this is C, B, and A. A, we have 3 forces, one for vertical, one for horizontal, and moment because it's fixed. So now summation for force horizontal forces equals 0. Horizontal, we don't have any force horizontal applied on the structure, so let's call this VA and HA, and this is the MA. So HA equal 0 because we don't have any forces on horizontal direction, and then go to summation of FV equals 0. FV, we have VA minus 1, this is the force, equals 0, so VA equal 1. Then summation moment at node A equals 0. Summation moment, we have the moment A because we have here, this is the moment, minus 1, this force that I assumed it equal 1, time distance is 3, so that's lead to MA equal 3 kilonewton time N. Then the second or the next step, to find the internal forces. This is our beam. This is C, B and A. (3m) and 2 meter. So now I will, and we have here the force 1 kilonewton. Now I will cut this part, the AB part, I will cut it, okay, because I want to check the moment at different points. So here I will, so the drawing, it will be like this. Here we have horizontal force with vertical force and moment, and here we have the 3. The 3 is the value of moment from previous page, and this distance is actually, I cut it from, I don't know from which exactly point or distance, so I will make it X. Then the X should be larger than or equal 0 and less than or equal 3, because the total length of AB part is 3 meter. Now I get I will calculate the moment M plus 3 anti-clockwise, 3 minus minus 1, the force, because it's to the down, time X equal 0. So M, my equation, it will be M equal minus 3 plus X. Then we have assume two values. If the X equals 0, and when the X equal 3, you can take more. You can make, like, for example, X equal 1, X equal 2, X equal 0.79, for example, up to you. But for this one, I just to choose the minimum value and maximum value only, but it will be same, don't worry. I mean, it's the value, it will be reduced when you take the x equal 0. For example, let me do now here. When x equal 0, the moment equal -3, and when we have x equal 3, the moment equal 0. So if we assume, for example, x equal 1 or x equal 2, the values, it will be between -3 to 0. For example, maybe you will get -1, -1.5, and the others values but here just assume the maximum and minimum values for displacement. And the other part is the B and C. It will be 0 because we don't have any support. So the figure is look like this one. For moment, here it will be 0, the moment, and here 0. This is point B, and this is here 0. So the direction, be careful with directions of moment. Here 0, here -3, this one, and here we have 3. Okay, so next step, found for TR2. TR2, this is our beam. And now working for moment. Moment, in example, we have 2 and change it to 1 kilonewton M. B, C, and A. 3 meter, 2 meter. So take moment around A equals 0. MA -1 equals 0, so MA equal 1. The other part is equal 1. You can check by your own. I will give you the just drawing for moments with value. This one, moment equal 1. This one, 1, and this is 1, 1. Be careful with the direction. So this should be like this. Sorry, I have mistake. Clockwise and anti-clockwise. Like this one, and clockwise direction. 1, yeah, this is correct. So these are moments, and all values equal 1 because we don't have any other forces. So now for our TR equal TR for TR1. TR1 is -3, 0, 0, 0, and TR2 -1, 1, -1, 1. Minus and positive depends on the clockwise and anti-clockwise. So here this is the minus, positive, minus, and this is positive. This is the matrix, and the R is 5 and 3, R matrix. Now go to find the value of R. Sorry, the value of forces equal after you multiplied the R matrix with TR matrix, so we will get the force minus 17, 2 minus 2, 2. This is the F matrix, so this is the internal forces. Now go to find the displacement. Displacement is delta and delta x. Delta x equals 0 because we don't have any settlement or other forces. Equal KRR, KRX, KXR, XX, R and X. Every element has X, it will be 0 because we don't have X. This one 0, this one 0, and this one 0. So we have only this part. Okay. To make it simple, delta equal KRR time R. R is 5 and 2, the force and moment that's give to you in the example, and KRR equal TR inverse F small f time TR. TR we already found it, and now how we can find the small f. Small f here is different than truss. It has a different rule. So now I will write to you the rule of F in the beam. So small f equal 1 6 EI to LA minus LA minus LA to LA. That's me. The LA is mean the first length of parts. Okay, so here 0 0 0 0 0 0 0 0. This is the first part. This is first part. Then the second part, same, but you should take the second length to AB, LB minus LB minus LB and to LB. And if we have, for example, member 3, one more member in your beam, you same rule but and same direction. Like for example, you will write 0 0 0 0 0 0 0 0, and here because I don't have enough space on my screen, it will be like this: 2LC minus LC minus LC to LC, like this. But here I don't have enough space, and maybe I can show you in the next video. So from this note we can calculate the value of small f and substitute your values. So let me to solve for you. F small f equal 1 over 6 EI. Here 6 because the length is 3. Minus 3 minus 3, 6, 0, 0, 0, 0, 0, 0, 0, 0. For number 2, 4 minus 2 minus 2 and 4. This is the small f for this example, and just substitute your f here in this rule. You will get the value of displacement, and I will give to you, and you can check with your own. So displacement kr equal 54 over EI, because we don't, the EI is constant here in this example, and 32.5 over EI. So that's all for this example, and how we can find the internal forces and displacement. So here I have a note actually for the truss. If we have indeterminate truss, if we have a 3 degree of freedom like this, I will draw same truss that I show you in the previous videos. Let me take same values of force. Okay, so this is number A, B, C, D, E, F. So I don't like to resolve again this example, but just I want to give you the notes. If we have more than 1 degree of freedom, so the first of all, when you want to check the structure, if it is determined or indeterminate, so the equation is n plus r minus 2j. So n, the number of bars, 6, plus the reaction here, it will be 4, because at node A we have 2, node B we have 1, and node, call it C, for example, we have 1 reaction, so it will be 4 minus 2. J is the number of joint 4. So these numbers will be give me equal 2. This is the 2 degree of freedom. So I will add it one more shape or figure for this, to solve this equation for the X system. If we go to previous video, we don't have support this one, so we got 1 degree, but here we have 2. So if we have 2 or 3, you should release another third part, but here we will release only 2 parts because we have 2 degree of freedom. How we can do that? The first of all, the first figure, it will be like this. This is make, you can make hind line because it will be released, and applied 1 kilonewton on horizontal direction, plus line, take this 1 kilonewton assumed. These are TR system, plus In this part, in the previous video, we assumed this one is like a force 1 kilonewton and 1 kilonewton. This is true, okay? But here we have 2 degrees of freedom, so I will add another 1 plus the other one is be the support, the roller support that I change it with or assumed is 1 kilonewton. Okay, and you can solve the equation. So this is Tx1 and Tx2, and both of them is Tx system. And you can continue to solve same steps with the previous videos. You can go it and find the internal forces and the reactions and the matrix and the others, what the question wants from you to find it. Thank you for kindly watching, and see you in the next video. Thank you.